So today we again have more integrals, but today is going to be a lot easier than last lesson. Today we have the fundamental theorem of calculus, and we are going to be using the evaluation theorem. So what that means is that we will find an integral, and then we will evaluate it on some interval a, b. So for this setup down here, it says the integral from a to b of f of x dx will give you the antiderivative of capital F of x, which you will evaluate on the interval a to b, which will give you f of b minus f of a. All right, so there is going to be no more constant of integration when we use the evaluation theorem. All right, so that's nice. As you can see here, there's no C. Yes, the formulas still have C, but we're not going to need them using this method. Okay. All right. And those formulas are there just to remind you of the integration formulas, the power rule, e to the x, 1 over x, constant rule, all that good stuff that we know already. So let's go ahead and try it out. One more thing. Okay. So example 1, we have the integral from 0 to 10 of 4 dx. So 4 is just a number. So this means that the antiderivative is going to be 4x. So this will become, I'll write this, you'll have 4x, and you will evaluate it from 0 to 10. Okay, which means that you always plug in the top of the interval and subtract the bottom interval. So we're going to evaluate this, and it's going to be 4 times 10 minus 4 times 0, which will give us 40. Now, of course, the question is, what does all this mean? What did we just find? And what we are finding is the area underneath a function on a given interval. So if I were to graph this out, oops, and we have to look at the original function there, which is 4. So if I said y equals 4, that would be the graph of a horizontal line. But now we are evaluating this function on the interval 0 to 10. So let's say here's 0 and here's 10. And this means that we now have a rectangle. And the bottom is a length of 10, and the height is a length of 4. And to find the area of a rectangle, well, it's length times width. So 10 times 4 would give you 40. So all we did was find the area underneath this function on the given interval of 0 to 10. So that's what we're doing here. We're finding the area underneath functions. Okay. All right, just a little explanation of what we're doing. All right, 2, let's try it again. The integral from 0 to 6 of x squared dx. So finding the antiderivative is going to use power rule, and we will get x cubed over 3 and evaluate it on the interval 0 to 6. Okay, so this will become 6 cubed over 3 minus 0 cubed over 3. And we get that 6 cubed, I think that is 216. Yeah, you'll get 216 over 3. and 0 cubed over 3 just becomes 0. Okay, so 216 over 3, well, 3 goes into 21 7 times, and 3 goes into 6 2 times. We get 72. And what we're saying is that on the interval from 0 to 6 of x squared, the area underneath that function on that interval will be 72. And again, if I drew another picture of what we were doing, here's the graph of x squared. And let's say that here's 0 and here's 6. So all we found was this area down below, which happens to be 72. Okay, good. So if you think about it, derivatives find slope and antiderivatives find area. So pretty crazy. All right. Next. All right. Before I move on, though, any questions so far?
No.
Okay. Let's keep going. All right. 3. The integral from 1 to 4 of 5x plus 3 dx. Okay. So for this one, you will get 5. Let me change colors. Let's see. There we go. You'll get 5 times x squared over 2 plus 3x. There's your antiderivative. So power rule on the x and then constant rule on the 3. So 5x squared over 2 plus 3x. And you will evaluate it from 1 to 4. Okay, so this time we will have 5 over 2 times 4 squared plus 3 times 4 minus, and put a parentheses or a bracket, whatever you want. I like brackets, keeps everything nice and neat. And you're going to plug in 1 this time. So you'll get 5/2 times 1 squared plus 3 times 1. Okay. And evaluate or simplify. This will be 5/2 times 16 plus 12 minus 5/2 plus 3. Okay. And 5/2 times 16, that 2, and that 16, that becomes an 8. So that'll give you 40 plus 12 minus, and inside here, since this is business math, why not make this 2.5 plus 3. And then we put it all together, 52 minus 5.5. And we should get 46.5. Okay. All right. Well, now I have a treat for you. Let's go to Desmos. Oh yeah, I had to reboot this. So there's no Desmos yet. Where are you? We'll use that. And there's Desmos and graphing calculator, sure. Okay, so Desmos is going to be your lifesaver here. And time saver as well. So what I'm going to type is the exact integral that I see on our paper. So I'm going to type in functions, I think you have to go to miscellaneous. And then in the bottom left corner, you see the integral symbol. So I'm going to type the integral. And it's going to have boxes where you can put the interval. So I'm going to put 1 there, 4 there, and then I'm going to type our function, parentheses, 5x plus 3, close parentheses, and then do it with respect to x. Like I said, you have to type it in exactly as you see it. So 5x plus 3 dx, and watch the magic that happens. We get 46.5. Oh, man. Now, isn't that nice?
Convenient.
So all I ask for your showed work is get to this part, find your antiderivative, and then plug it in and just give me the answer. That's it. So unless you want to keep going the long route, that's totally fine. But again, to make your work easy, stop here and give me the answer. But remember, make sure you are plugging in the original problem. If you plug in the antiderivative, you're going to get something different. So you have to plug in the original. Okay. So I'll keep that up and we'll keep going. So for the integral from 0 to 1 of e to the x dx, well, the antiderivative of e to the x is e to the x, which we evaluate from 0 to 1. And if I use Desmos, of course, I get the integral from 0 to 1 of e to the x with respect to x. There it is. I get 1.718. That'll be fine. 1.718. And does that save us a bunch of time?
Yes.
Sure does. All right. Perfect. All right, let's keep going. 5, the integral from 1 to 2 of 1 over x dx. Okay. So again, we have, the antiderivative of 1 over x is the natural log of the absolute value of x, which we evaluate from 1 to 2. Okay. So come back to Desmos. The integral from 1 to 2 of 1 over x dx. And there you go. We have 0.693. I'll do it to 3. My math lab may ask for 2 or 3. Just read that fine little blueprint for when it asks for the decimal number. Okay, not bad. Still going. 6. You have the integral of -2 to 2 of x cubed plus 7x dx. All right. So for x cubed, this will be power rule. You'll get x to the 4th over 4 plus for 7x, that x will get power rule, and you'll end up with 7x squared over 2. And you evaluate it from -2 to 2. Okay. And once again, Desmos for the win. -2, 2. And type in exactly as you see it. X cubed plus 7x. Close that with respect to x. And we get an area of 0. All right, cool. Guys doing okay now?
Yep.
Life is easy now, huh?
Yes, sir.
It's a relief.
Calculators for the win. Okay. 7. The integral from 2 to 5 of 2x plus 9 equal to dx. So this will give me, first one is power rule. So you'll get 2x squared over 2. Second one is constant rule. The antiderivative of 9 is 9x. And we will evaluate from 2 to 5. I can actually simplify this one more time and just make it x squared plus 9x because your 2's cancel there. Okay, and we're evaluating from 2 to 5. All right, and remember to type in the original problem. So integral 2 to 5, oops, parentheses 2x plus 9, respect to x. We get 48. Okay. 8, the integral from 2 to 3 of 6 minus x cubed. All right. 6 gets the constant rule, so you'll get 6x minus x cubed gets power rule. So x to the 4th over 4, evaluated from 2 to 3. Okay. So there's 2, there's 3, parentheses 6 minus x cubed with respect to x, and we get negative 10.25. Okay. All right, not bad. All right. 9. The integral from 1 to 2 of 2x to negative 2 minus 3. Okay. So x to negative 2 gets power rule. So this will become 2x to the negative 1 over negative 1. 3 gets constant rule, so that'll be minus 3x. And we evaluate from 1 to 2, but of course I want to make it look pretty. So I'm going to rewrite this as negative 2 over x minus 3x. There we go. And we're evaluating from 1 to 2. Okay. Type in the original problem. Integral from 1 to 2. Parentheses 2x to the negative 2 minus 3. Close that. Respect to x, and we get negative 2. All right. The integral from 1 to 4 of 3 square root of x dx. So we're going to have to first rewrite this. Actually, I can rewrite. Oh, no, I'll keep that there. I'll keep the 3 there. So I'll have 3 x to the 1/2 dx. So we change the square root into a 1/2. And then you apply power rule. So you get 3 times x, and remember you add 1 to 1/2. So 1/2 plus 1 is going to give you 3/2 over 3/2. And we're going to clean it up before we evaluate, which means I'm going to flip that denominator. And that 2 is going to come to the numerator, and you will get 6x to the 3/2 over 3, which actually reduces to 2x to the 3/2. And now we evaluate it from 1 to 4. Okay, so over here, type in the original problem, the integral from 1 to 4 of 3 square root x with respect to x. And we are going to get 14. All right. That's good. All right. Everybody good with those?
Yeah.
Okay. Okay. Which means that we're on our last one. All right. Number 11. A company manufactures mountain bikes. The research development produced the marginal cost function C prime of x equals 500 minus x over 3 from 0 to 900, where C prime of x is in dollars and x is the number of bikes produced per month. Compute the increase in cost going from a production level of 300 bikes per month to 900 bikes per month. Set up a definite integral and evaluate it. Okay, so we are going to set up our integral, and they gave us an interval. They said that we want to go from 300 to 900 bikes. So this means that for our integral, it's going to be the integral from 300 to 900, and we are going to find the integral of C prime of x with respect to x. Okay, and now we'll plug in what C prime of x is. So that's 300, that's 900, and we'll have 500 minus x over 3 dx. Okay, so now we can find the antiderivative, which means, let me just clean this up one more step. I'm going to rewrite this as the integral from 300 to 900 of 500 minus 1/3 x dx. So x over 3 and 1/3 x are the same thing, which means now go ahead and find the antiderivative. 500 is a constant, so this will just become 500x minus 1/3 times, and this x will get power rule, making it become x squared over 2. Okay, and now one more step before we evaluate it. You get 500x minus 1 over 6x squared. So everything's nice and cleaned up. We will now evaluate it from 300 to 900. And to get that numerical value, well, of course, I'll use Desmos. And we're going from 300 to 900, parentheses, 500 minus, and I can type it in as I wrote it, 1/3 x dx. and we get 180,000. So for this problem, it said compute the increasing cost going from a production level of 300 bikes to 900 bikes per month. So if we go from 300 bikes per month to 900 bikes per month, costs will increase by $180,000. And there it is. Those are antiderivatives with evaluation theorem, a theorem that is part of the fundamental theorem of calculus. So you take the antiderivative and you evaluate it by plugging the numbers in. And our calculators make that work a lot easier for us. Okay, so we are done.